This is the last section of notes in 6.1. We're going to be looking at relationships among living things, so biotic relationships. And so if we're studying just living things, so if we'll circle biotic, if we're studying just living things, we're studying the community. Before, when we were studying things like carbon and the water cycle, we were studying abiotic and living, and that was the ecosystem. But now we're just looking at relationships between living things. So we have a couple different types of relationships we might see. One is competition, a struggle for resources among organisms. This can look like competition in animals. Maybe you're competing for a mate. Maybe you're competing for food. Maybe you're competing for space. Competition is where you're struggling for, and we want to add in the word, limited resources. A struggle for limited resources among organisms. Remember, this can lead to natural selection. If we have a limited number of resources and we're competing, then we have that idea of survival of the best fit, who has the best adaptations. We can also see competition in plants. It's not just in animals. It's in bacteria and protists and fungi. And so in plants, one of the big things that they have to compete for is sunlight. So competition is an example. So is what's called the predator-prey relationship. That is a relationship between living organisms. The predator feeds on the other organism. The prey is the organism being fed upon. Most people are pretty familiar with predator-prey, but what we have to keep in mind is that we see that this impacts or influences the size of the population. If we have a really big predator population, then that's going to affect the size of the prey population, making it smaller. And then if we don't have very many prey, not very many predators will survive, and the predator population will get smaller. But then there are fewer predators, so more prey can live. And so if you'll draw this little graph with me, we see that they go up and down, and that they kind of do what's called lag each other. If one population is really high, the other population is usually really low. And so we start to see these relationships between organisms. There's your predator and prey. We don't usually call herbivores predators because they don't actually have to seek out any organisms.
Nick Charles, please go to Student Services. Nick Charles, please go to Student Services to see Miss Minute.
This is where we're going to put a big star. Symbiosis is going to be a pretty new term for us. Sym means together. So symbiosis means living together in a permanent relationship. And we do need to make a note that this is two different species that live together. We're not talking about a bluebird and a bluebird living together. That's not symbiosis. It's two different species. The first relationship that we see is called mutualism. Mutual means both. And so here we see that both organisms benefit. And so we call that a plus-plus. One of the really interesting examples is with termites. Now, humans tend to think of termites as a negative thing because they can eat the wood in your home. However, inside of a termite is a tiny little microorganism because it turns out termites can't actually digest wood. They can chew it up in their mouth, but they can't digest it in their intestines unless they have this little organism living there as well. And so we see that some examples, I want to go back. An example of mutualism, we need to add that in here. An example is the termite and the protist. But another example is actually humans and some bacteria. We actually have some bacteria in our intestines that help us digest our food. We benefit because our food gets digested, and the bacteria benefits because they have a place to live. So mutualism is where both are benefiting. Next we see something called commensalism. And commensalism is the one that you're probably going to also need to put a star by this word. It's going to be a difficult word for us to learn. It's where one organism benefits, that's the plus, and the other is not benefited or harmed, and that's the zero. So commensalism can be remembered as plus zero. One benefits and one gets nothing. If you notice this O here, that's how I remember it. Commensalism is the only one of our words with the O in it. You'll notice that all of these relationships always have someone who has a plus sign, someone who's benefiting. No relationship that's permanent would have both that are being negative. So commensalism is, for example, where the Spanish moss grows on the tree. It doesn't harm the tree, so the tree isn't hurt, tree doesn't benefit, but the moss gets a place to live. Another really good example are barnacles and whales. Barnacles are a tiny animal that lives in the shell, and it actually will attach itself to the back of a whale, so that as the whale swims, the barnacle can pull food from the water. That's a plus for the barnacle. The whale isn't hurt by the barnacle, but also isn't helped. So the whale gets a zero. And that's commensalism. And the last example is called parasitism. One organism benefits, there's the plus, and the other is harmed. Now we use a minus. One example is a tapeworm. You probably recognize the word parasite. For example, a flea, a tick, a mosquito, those are all parasites. They're benefiting while humans are being harmed. And so those are the three examples of symbiosis. And so what we notice is that the populations are going to affect each other. So the last part of our notes is about something called population growth. How big does the population get? Now we want to remind ourselves, a population is talking about just one species. So for example, we might be talking about just the giraffe, or just the sunflower, one type of species. As organisms reproduce and populations increase, that's an important part. The more you reproduce, the bigger your population gets. But the more we reproduce, the more resources will limit the growth. Resources such as food, space, water, mates. And so as the population gets bigger, we're not going to have enough for all organisms. Populations will come to an equal, where they're not growing and not shrinking, but they're just what we call stable. So the first type of pattern we see is what's called a J-curve. It's a period of exponential growth. Sorry, I want to say one more thing about that. When we have exponential growth, we also want to write the word unlimited. It just grows and grows and grows and grows and grows, and so you can see that it looks like the letter J because the population is just growing really quickly. However, this isn't what most populations look like because most populations get limited, and that's called an S-curve. The population growth stabilizes as what we call carrying capacity is reached. And so you can see this letter S here. And you can think of the letter S and the letter S in stabilizes. It comes to a stable or secure number, and we call that the carrying capacity. And you want to circle and star this word. When you think of carrying capacity, think of like a backpack. There's only so much you can fit in a backpack until the backpack breaks. And so the carrying capacity is the number of organisms that can survive. One quick thing to note, if we just looked at the growth until here, we'd see kind of the letter J. But eventually it levels off and approaches this carrying capacity. Carrying capacity, as we said, is the number of individuals an environment can support. I'll come back to that. And so when we look at this picture, we see that the carrying capacity is a defined number. And what happens is we have to look at how many are born and how many die. If we're at carrying capacity, we can only support the number of organisms being born as the same number that are dying. And then we'll stay right at carrying capacity. If we add any new organisms without any dying, then we actually end up being over carrying capacity, and some organisms will die just from competing. So carrying capacity is found when we see what's called logistic growth. When we reach a limit, or the carrying capacity, it's determined by limiting factors. Resources that control the population and create the carrying capacity. So however big that carrying capacity is, it's because of how many limiting factors we have. Food, space, water, and disease. These are all examples. And diseases can be things like AIDS, influenza. Plants have diseases as well. And so this is the end of the notes, where we start to look at this big picture of, if I look at an organism like a deer, and I look at the whole population of deer, I need to know how big that population can be, and what might affect the population of deer. But I also need to look at the interactions between deer and other organisms and their environment. And so that's the end of section 6.1. Please make sure you do your summary box.